Hi everyone, my name is James Dominic. I'm a PhD student at Clemson University. I work with Dr. Paige Rodagero at the Human Factors Software Engineering Lab. Today I present my work on remote pair programming in virtual reality. During the time of this pandemic, it has become a requirement that software programmers work remotely. It is projected that 25 to 30% of the workforce will be remote by the end of 2021. However, remote collaboration is not always easy. Remote collaboration often suffers from problems when people work in different time zones or when people do not have enough availability for in-person meetings. Right now, the most common tools which are used for collaboration among software programmers are Microsoft Teams, Skype, Slack, Google Meet, TeamViewer. Our goal is to bring programmers together into the same virtual space, into a shared virtual space, so that they have an increased social presence with their fellow collaborators. Virtual reality as a tool has been used in a wide variety of research areas, including medicine, therapy, gaming, training, education, and architecture. However, the use of virtual reality in software engineering has been very limited. Most of the work, most of the existing literature in virtual reality and software engineering concerns visualization of code in virtual environments. We, with this paper, we aim to address the gap in literature, in software engineering literature, working with virtual reality. We developed VirtualDesk to allow programmers to collaborate in a virtual environment. The VirtualDesk system was developed in Unity 3D. We used HTC Vive Pro headsets. We 3D printed mounts which were used to mount the HTC Vive trackers to track the keyboard and the mouse. We used leap motion controllers to provide hand tracking. We also use the Windows Desktop Mirror API to project the user's desktop into the virtual reality environment so that the user can see the desktop while working in the virtual reality environment. We also enabled a collaboration feature where both programmers get the illusion of working on the same system by using TeamViewer in the backend. The programmers were visualized using partial body avatars as shown on screen, and they were able to see each other in the same collaborative space. They were also able to do hand gestures using their hand, using the leap motion hand tracking. We also tracked the keyboard and the mouse and provided visual feedback when the user pressed the keyboard or the mouse. So we can see that in this image that the Z button on the keyboard is pressed and the button lights up in blue and goes up and down. Similarly, the mouse button, the left mouse button is pressed, which is highlighted in white color. So we aimed at addressing three research questions during this study. The first research question was, do remote programmers fix more bugs using VirtualDesk versus using TeamViewer? Second research question was, what is the difference in time taken to fix the bugs in VirtualDesk versus TeamViewer? The third research question was, is there qualitative evidence that virtual reality collaborators have more difficulties with collaboration as compared to traditional remote programmers? To study these research questions, to answer these research questions, we conducted user studies. We had two different experiment settings One was the virtual pair and the other was the remote pair. The virtual pair setting used the virtual reality system which we developed called VirtualDesk. We recruited 20 professional programmers who worked in pairs doing pair programming in VirtualDesk. These programmers came from organizations like General Assembly and PowerPlan. They were recruited from the Atlanta area. The remote pair setting programmers in the remote pair setting, programmers used TeamViewer to collaborate. We pro, we recruited 20 professional programmers who pair programmed using TeamViewer. These programmers came from organizations such as IBM, Oracle, and NVIDIA. We recruited these programmers from all over the United States. We had 9 different games as listed on the screen, which we found on GitHub, and introduced 15 different bugs into these programs. These programs were all written in Python, and the programmers were allowed to debug this code using Visual Studio Code. We provided a Windows operating system for all the programmers in both settings to use while during this experiment. So this is the basic outline of the user studies. At the beginning of the user studies, programmers in both virtual pair setting and the remote pair setting were given introductions to their respective environments which they work in. The virtual pair setting programmers were introduced to the VirtualDesk system, and the programmers in the remote pair setting were introduced to the TeamViewer setting and ready to go before they started pair programming. These programmers in both settings pair programmed for 40 minutes solving various bugs. The programmers were allowed to choose whichever bug and program they wanted to start working on in any order they wanted. We collected the data in the form of number of bugs solved, the amount taken to solve each bug. We also collected survey data from all the participants which had self-reported values of productivity and collaboration difficulties. These are the results which we got from the study. To answer the first research question, we looked at the number of bugs fixed in both settings. We see that in virtual pair setting, programmers solved a total of 18 bugs, whereas in remote pair setting, programmers solved a total of 10 bugs. So here we see that using the VirtualDesk system, programmers were able to solve more bugs than using TeamViewer. To answer the second research question, we looked at the time taken by programmers in each setting to solve the bugs. We found that programmers in the virtual pair setting spend 45% of their time successfully solving bugs, whereas programmers in the remote pair setting spend only 23% of their time successfully solving a bug. That means programmers in the virtual pair setting solved 2.67 bugs per hour, whereas programmers in the remote pair setting solved only 1.48 bugs per hour. We also, to answer the third research question, we conducted a man-Whitney U test on the self-reported perceived productivity and understanding of source code, and we did not find any statistically significant differences in collaboration difficulties between either of the platforms. So the observations from the studies shows that programmers using the virtual reality environment were able to solve more bugs and were able to solve the bugs faster. Whereas we did not find any qualitative evidence for statistically more collaboration difficulties between virtual desk setting and the remote pair setting. Thank you.